Hi guys. Lesson 11. Lesson 11 is incomplete dominance. Right, if you look at the exam guidelines, well, there are exam guidelines. So what have we done so far? We have done the genetic crosses. We're going to do some questions today. I'm going to give you homework. So don't go to the next lesson after this. Don't go to lesson 12 before we are done. Before you have done the homework from lesson 11. Why? Don't go to lesson 12 before you have done with lesson 11, because in lesson 11 I'm going to give you homework to do. So in lesson 12 we're gonna go back to into the questions, and then we work them out, and then we figure out everything, and then we get sorted. Right, just give me a second here. I need to put my timer on. Right, so what was I saying? We have done the format for genetic crosses. We have done Mendel's principle of segregation, and we are in types of dominance. We have done complete dominance. Right, and what have we learned from complete dominance? Is that, where is my thing? Give me a second. What have we learned from complete dominance? That when one allele is dominant over the other, you are going to have a situation, where are you? Where it is completely dominant over the other, you are going to have a situation where if the allele that is dominant over the other, the one that is recessive, when they are found together forming a gene pair, making up the genotype for that particular characteristic, you will find that the allele that is dominant is the allele's characteristics that are going to be exhibited in the phenotype. Right, so we did complete dominance. Today, we're going to look at incomplete dominance. Now, what is incomplete dominance? Let's blow this up for you a bit. Oops. Right. Let's see if we can center this a bit. Remember that you need to have your exam guidelines with you. Right, what is incomplete dominance? This is a situation where none of the two alleles of a gene is dominant over the other, and this results in an intermediate phenotype. We're going to go into this research here. This results in an intermediate phenotype. Let me say this now, and I'll repeat it again later. You cannot describe incomplete dominance without writing intermediate. If you get a question that is talking about genetics and the offspring and crosses, and then you are told in that question that an intermediate color or result, the moment you hear intermediate, then you know the clue should be what? Incomplete dominance. Right. I hope you're getting that. I hope you're getting that. Where are you? Right. Walk with me. So what are we saying? Alleles are not always dominant or recessive. It's not always the case. I know that we're now used to dominant over recessive and everything like that, but it's not all characteristics that exhibit complete dominance. Right. So not all alleles are dominant or recessive always as in complete dominant. Right. Sometimes two homozygous individuals are crossed, and the offspring's phenotype expresses, what did I tell you? An intermediate form. Right. You can write intermediate form, or you will hear it being described as a blend. Why either one of these two is your answer? For example, if you are asked what kind of dominance is being exhibited, and then you say that it is incomplete dominance, then the follow-up question says, explain your answer in the question above. Then you say that no, it is incomplete dominant because, depending on what the question was, the offspring exhibited an intermediate, whatever color it is, or whatever situation that you're given, or a blend. So when we are talking about incomplete dominance, look at this. In complete dominance, you have tall in P-plants being dominant over what? Short. So when tall and short, when the alleles are together like this, you know that the phenotype is going to be tall. Because who tall is definitely dominant over what? Short. But in incomplete dominance, right, there is not one allele that is dominant over the other. There is not one. So you will find that when you cross two homozygous individuals, when you cross them, and you find that the offspring, instead of exhibiting one of the phenotypes of the original cross, one of the phenotypes of the parents, you will find that the offspring, instead of showing one between one of the parents, their phenotype, and then it's reflected what? In the offspring. You get instead the offspring giving you a blend. In other words, you are getting a blend of the phenotypes of the parents who make the offspring. I hope you're getting it. I hope you're getting it. So sometimes two homozygous individuals are crossed and the offspring phenotype express an intermediate form or a blend of the two parents' characteristics. We're going to go into it. So in other words, what are we saying? We are saying that neither one of the alleles dominates the other. Neither one of the alleles dominates the other. There's no one allele that is. So if this is known as what? Incomplete dominance. I want to look at an example of incomplete dominance, and I want to use snapdragons as an example. Right. Snapdragons. Give me a second. These are snapdragons. Yes. Where is the one that I want to use? Yes, let's use this one. Let's use this one. Give me a second. Right. These are snapdragons. I hope the color looks fine with you. But snapdragons are flowers that come in two forms. You have red in three forms: red, white, and pink. If you take a red flower and you take a white flower, and if they cross together, what you're going to end up with is an intermediate. You're going to end up with an intermediate form, and that intermediate form will give you what? Will give you pink flowers. Where are you? There we go. Give me a second. Pink. There we go. So you end up, so what do you have? If you cross a red snapdragon and you cross it what? With a white snapdragon, what do you end up having a result? Pink. Flowered snapdragons. What is the pink? The pink is a blend. It's a mixture. A blend. Or the pink is an intermediate form. It's in the middle of red and white. So it's a blend. Meaning that when it comes to the characteristic of flowers in snapdragons, you will find that the characteristic does not exhibit complete dominance, but it exhibits what? Incomplete dominance. Now, since it exhibits incomplete dominance, how do we then do the cross? Right. Because it is incomplete dominance, where there is not one allele that is dominant over the other. If there's no allele that is dominant over the other, then what you're going to have a situation is that we are only going to use what? Capital letters. Why? Because if there are any small letters, that indicates what? Complete dominance. So we're going to use different capital letters. So for example, those snapdragons that produce red flowers, if they're producing red flowers, what do we use? Capital letter R. And if they're producing what? White flowers, what do we use? Capital letter W. Those are the symbols, whatever symbols that you use. But you will see that in questions, they will usually give you a key that use this, let this letter R be for red flowers. Let the letter W be for white flowers. But again, let me stress this. In incomplete dominance, you do not have small letters in your crosses. You don't have small letters in your crosses. Right. Why? Because if you have any small letters, what does that mean? That means that you're going to have a situation what? Where one is dominant over the other. Right. Walk with me. Let's do a cross. Let's do a cross. A homozygous snapdragon. Homozygous snapdragon plants with what? Red, capital letters are flowers, is crossed with a homozygous plant with what? With white, in brackets what? Capital letter W, flowers. How then do we do a cross like this? And then what is the result of this? All the offspring are pink. That is incomplete dominant. How do we do this? Let's do the cross. So a homozygous red flowered snapdragon is crossed with a homozygous what? White flowered snapdragon. And all the offspring are pink. Right. Again, assuming that you have not been instructed, you have not been led by the question. Let's just assume the worst. You haven't been led, you're just told to do a cross. The very first thing that you do is what? You do a key. So an R, capital letter R is what? Red flowers. Capital letter W is for white flowers. I don't like writing R red. Red what? You understand what I'm trying to say? I don't like writing W white. White what? You understand what I mean? So you need to be descriptive. R is for red flowers and then W is for that. What have we been told? We have been told that a homozygous red flowered plant. So red flowers is crossed with what? With white flowers. And then you put your labels. You need to put those labels because that's the format of a genetic cross. And then here, what is this? Homozygous. We are told that it's homozygous, so it's capital letter R crossed by homozygous white. What is the next thing after that? It's meiosis. This is P1 generation what? Genotype. P1 generation. Phenotype, what is this? Meiosis. And then this one, according to Mendels's law of segregation, this allele is going to end up in its own gamete. This allele is going to end up in its own gamete. This allele is going to end up in its own gamete. This allele is going to end up in its own gamete. You can use whichever cross you like, the traditional cross or the Punnett square. But I think now you're getting the traditional cross. So let's do the Punnett square. What do we have here at the bottom? We are going to have our box. What is here? Gametes. These gametes, let's drop them into here. These gametes, let's drop them into here. Hope that makes sense. Right. What am I looking for? What am I looking for? Let's go. For this gamete here, it can fuse with this one, or it can fuse with that one. So this gives you, this gives you, this, this, and what is this? Fertilization. In a cross like this, where the offspring are few, you only have 4. Sorry, give me a second. What is the end result here? You're going to end up with or what? 100%. So whichever one you want to use, whichever you want to use, you can say O offspring or F1. What is this? F1 genotype. And then O offspring what? Pink flowers. And what is this? F1 generation what? Phenotype. I hope you got that. Right. You remember when Mendel did the initial process, he was crossing homozygous for tall, homozygous for short. And then he crossed, and then what did he get? All the offspring were tall, but their genotype was what? Heterozygous. In this one here, if you take what is the initial cross in incomplete dominant? It is homozygous. Homozygous for red, homozygous for white. And then when you cross them, you end up with all offspring being what? Exhibiting the intermediate form, which is the pink flowers. Now, what happens if we take the same concept as the one that we use during complete dominance? What happens when we take the pink flowers and we allow them to self-pollinate? We allow them to what? To self-pollinate. Let's do it. Let's do it. Let's just say that Mendel went further, of which we're no longer talking about Mendel, but we're not longer talking about him specifically concerning, because snapdragon flowers, Mendel's experiments initially were on what? Complete dominance. Are we together? But let's just say that we take the pink, allow them to what? To self-pollinate. What would that cross look like? Again, you write what? Key. What's your key? Is for what? Red flowers. What is this for? White flowers. If I'm going to do a cross where I am allowing the F1 offspring to then self-pollinate, I'm going to end up with my phenotype. F1 offspring grow up to become what? P2. Are we together? Right. So if I'm taking P and I'm allowing it to self-pollinate, then this becomes what? My P2 generation what? Phenotype. What is my genotype? That's the genotype. Is that also? What is that? P2 genotype. Again, what is that? Meiosis. I don't have time to write it. You are supposed to write it. Right. This one goes into its own garment, this one into its own garment, this one into its own garment, this one into its own garment. And what is that? That is your F2 garment. So this is your garment. This is your meiosis. Right. Walk with me. Let's do the traditional cross. I like mixing them up. You can use whichever cross you want, except for dihybrid. Otherwise, for these crosses here, where you are looking at one characteristic, you can use whichever cross. You can use the traditional cross, or you can use the Punnett square. Right. Let's use the traditional cross here. We'll do fertilization now. This one can fuse with this one, and this one can fuse with that one. Is that not so? Yes, it is. So, this one can also fuse with that one. This one can fuse with this one. Now bear in mind, look at this. This was W and this was R, but yet I wrote it in the same format. Whichever allele that you're going to start with is the same allele that you start with all the time. And then this one can fuse with this one. Fertilization. What is this? F2. Generation what? G. No type. Right, let's do the phenotype. You have 1 red flowers, is to what? 2 pink flowers, and is to 1 white flowers. What is this? F2 generation, phenotype. Are we together? Right. What conclusions do we see? In other words, our phenotypic ratio, when we are looking at incomplete dominance, our phenotypic ratio, when we are looking at incomplete dominance, in a case whereby the two that are being crossed are heterozygous, in a case where the two that are being crossed in incomplete dominance are heterozygous, then you will find that the ratio will always remain as what? 1:2:1. The phenotypic ratio. All the time. So for example, in this question here, in this one here, you have your 1 red flowers, 2 pink flowers, and 1 white flower. Don't forget this, that when you cross heterozygous traits for 2 individuals, when you cross them together and both are in a heterozygous condition, then in incomplete dominance, you are going to have one of the other. So in this case here, you have one that's going to be red, one that's going to be white, and you're going to have 2. Showing what? The intermediate form. Do not forget it. Right. I hope that you got that. We're done with that. We're done. I hope you understood that. I hope you really did. I had homework for you. Past exam papers. I don't give homework from anywhere else. I give past exam questions. Why? So that you don't get scared when you write exams. And I think we've moved enough sufficiently that you can get homework now. Where are you? Paper 2, last year, November 2019. Paper 2, November 2019. Your first homework, question 1.5. Question 1.5. Question 1.5. Go download the exams, the exam papers. If you don't know where to download them, I'm writing there. EC exams.course. Go and download 2019 paper 2, November exam. Do question 1.5. Do question 2.3. Do question 2.3 and then do question 2.4. So what is your homework? Your homework is from November 2019. What? Paper 2. What are the questions? Question 1.5 and question what? 2.3. Sorry. This is 2.3. 2.3. Question 1.5, question 2.3, and question 2.4. We'll do these 3 questions. Don't look at the memo. Go and do it, and then when we come back next lesson, then we'll revise it together. Yeah, so I hope you understood incomplete dominance. I'm going to be giving you questions every day now because you have time now. You have enough basics. So yeah, look at that, absorb it, and then we'll see you in the next lesson.